Hi ladies, so I said I'd make a little video on your optional topic because it can be a little bit confusing what your optional topic is because there's a number of different sections in the back of your workbook. So your first optional topic is going to be on industrial chemistry, and basically the way this works is that you need to know a case study and you need to know under certain headings. So it's just really learning off, so it's a nice one to do if maybe your maths and the calculations aren't your strong point, okay? So let's start off. Okay, so industrial chemistry. So the case study we're going to use is the production of ammonia and urea in IFI Cove, okay? So let's start with our key definitions first of all. Now this is similar to what we do in biology if you do biology with me. You've got two types of processes, batch processes and continuous process. So a batch process, girls, is where reactants are added, the reaction occurs, product is formed and the reaction is stopped. And that's really suitable for small scale processes. Continuous processes are more expensive, they're more difficult to do, and they occur usually in larger companies, okay? And raw materials are continuously added and the product is continuously formed and removed, okay? So it's done where you're kind of making something that's very valuable on a really large scale, and you want product constantly produced, okay? Now let's look at the positives and negatives there before we move on. So for batch, your positives are that your vessel is usually small, quite a small scale production. The vessel can be used again and again and again for different types of reactions, but that means contamination is possible, because if the vessel isn't cleaned properly between different batches going in, then you can have different products coming out too. If you look at your continuous scale, the positives and negatives of that can be done on a large scale, low risk of contamination because you only have the one product being formed. You only have the one product being formed at all times. And the negatives are that it has to be custom built to fit the plant. Now these are the key terms that you need to know when you're talking about your case study. So feedstock, essentially that's your treated raw material, your purified raw material that's going to be added at the start of your process. Your yield, how much product you're actually going to get out. Okay, remember, product is the valuable thing that you're looking for. You want as much as possible to make as much money as possible. Co-products, have you formed anything you shouldn't have? If you have, how do you remove it? And can it be useful for any other processes? Waste disposal, it's very important that you're getting rid of your waste in a sustainable and environmental way. And effluent control is obviously the same, getting rid of your water waste that may have been used during your process as well, or your liquid waste that may have been used during the processes. QC, quality control, how is your product quality controlled during the process? Safety, how do you ensure the safety of your staff and the safety of those living around your site? Costs, what type of cost do you have to think about? Site location, construction materials is the last heading that you need to know your case study under. So let's skip on and just have a little look about what our case study involves. So our case study involves the production of ammonia. So you've got nitrogen reacting with hydrogen to form NH3, which is ammonia. So you need to know that equation there. And it's done in the presence of a finely divided iron catalyst. Okay, now ammonia is really useful because it can be used in explosives, it can be used in the production of nylon, it can be used in the production of urea, which is used in fertilizers. So urea involves the treatment of carbon dioxide, or the reaction of carbon dioxide with ammonia to give ammonia. There's your urea, which is your NH2CO, NH2 with your water. Okay, so urea is a really useful farming product for fertilization. Okay, so really, really important for fertilizers. So they're your two products that we're going to focus the production of. Okay, so all of this occurs at the IFI in Cove in Cork. Okay, so that's important because we'll talk about the location of that plant now in a second. So this is what's called a Haber-Bosch process. So these are the chemist and the engineer who designed the process to ensure that you got the maximum amount of products. Okay, so like I said, you need to know that equation and you need to know the catalyst used. Now your feedstocks, your starting materials, girls, your raw materials are your nitrogen, which comes from air, because nitrogen is 78% of the air around us, okay, or the atmosphere around us, and hydrogen comes from the steam reforming, or the This is called steam reforming of methane. So it comes from natural gas reacting with water. So there's our equations for that there. So you've got methane reacting with water to give carbon monoxide, which is obviously very dangerous, and your hydrogen. And then we can get rid of the rest of that carbon monoxide by reacting that with more water to get more hydrogen, which is great. So we're getting more start material there. Now your carbon dioxide here is a co-product or a side product, which you don't want, but we'll talk about its use later or its treatment later. Now, in terms of rate, how we keep the rate fairly high to make sure that our product is forming quickly. We use a high pressure, 200 atmospheres. We use a fairly high temperature, 500 degrees Celsius, and we use small particles of iron catalyst. So to make sure that the small particles means that there's a faster reaction rate there, okay? Now, this is linked to your equilibrium reactions here, girls, okay? So if you see this, these are all gases, okay? And you have 4 gas molecules on this side, 2 on this side. So if I use a high pressure, I am encouraging my product to form, okay? Now, the Ford reaction is actually an exothermic reaction, so low temperatures favour the production of the product. But remember, we need to have some sort of temperature there to encourage the particles to be bouncing around and reacting together. So we use an intermediate temperature of 500 degrees Celsius. Now it's still quite hot, but it is an intermediate temperature there, okay? So that's how we keep our rate high. That's how we keep our rate high. Your yield then, 17% yield. So not a great yield, but look, it's the best yield we can get. So it's still a very valuable product, so it's still worth doing. Our co-products, we produce carbon dioxide during the steam reforming of methane, and we can use that we can use it by selling it to fizzy drinks companies and making fizzy drinks from it. Okay, so they're actually quite clever in how they use their co-products. Now, waste disposal and effluent control. So obviously it's really important for all companies to be getting rid of their wastes in sustainable ways. So the EPA monitor all chemical companies to make sure that they're not releasing it in dangerous into the environment. Recycling lowers emission of ammonia as well, because remember, if ammonia is released, we could lead to eutrophication of the rivers, which would be a really bad thing. Remember the overgrowth of algae. In terms of our quality control, we use different methods of spectroscopy to ensure our product is produced pure. Okay. In terms of safety, we use personal protective equipment, glasses, lab coats. There's firefighters, because we're creating explosive chemical. Firefighters on site at all times, and also staff training occurs to ensure people are aware how to safely behave with the chemicals as well. And then your costs. So you've got lots of costs in relation to this. You have to pay for your starting materials, your methane, okay, your water, and you have to pay your staff, to pay your waste, you have to pay your running costs, your electricity costs as well in the company too. Okay, construction. The plant construction is made of stainless steel, and it has to be quite thick stainless steel to withstand the temperatures and pressures that you're putting under your reaction under, okay? The last thing to think about, girls, is site location. So do you remember I said that is present in IFI Cove? So Cove, girls, is on a little peninsula in Cork. So that means that they're able to come along by boat and remove this product and transport it all over Europe, your ammonia and urea. The other thing about Cove is that it's very close to UCC in Cork, so there's a trained workforce available from UCC which do science undergraduate courses, okay? So its location is perfectly matched. It's also on the train lines too, so it's able to transport its products around Ireland. So that is our case study, girls. That's our industrial chemistry, and I hope that's okay. I'll put these up by picture as well. Thanks, girls.